Hello, and welcome to my presentation on data flow notations. These notations are used in drawing diagrams to gain a better understanding of the requirements of a system before its actual implementation. A system may be a manual procedure, a software system, a mechanical system, a hardware system, or any combination of these systems. The diagrams we draw show the data flow through the system and its components. The notations are very simple, and yet we tend to violate these basic conventions whenever the system complexity increases or face difficulty in the actual modeling process. Let's make sure that the first step in the validation of these diagrams is to ensure we conform to these notations and conventions. We use four notations: a rectangle to represent an external entity, a circle or a bubble to represent a process, and parallel lines to represent data stores or databases, and a labeled arrow to represent data flow in our system. An external entity is any outside person, unit, organization, or system that interacts with our system under development or under consideration. We use descriptive names and we use singular noun. It's not good to use plural because that will complicate your modeling activities, and it will lead you to think about repetition, which is not appropriate in data flow modeling. The process, actually, it's very simple. It's the work that needs to be performed, and therefore we suggest using active action verbs when we try to describe the name. And the name that you give to your process must convey a meaning and give a sense of the computation that needs to take place. Data store, on the other hand, is data that's stored for later use. This data is persistent and outlives the execution of your processes, and we have to make sure that we label uh, this databases with um, plural nouns, because for example, if you're thinking in terms of employee database, you have employee records. Um, Data stores are convenient for us to use, and that's data at rest. So it's really data that's residing in a file system or in an actual database. The data flow item is data in motion. It's transitioning from point A to point B, and they're used to represent our inputs and outputs of the system. And it's important that you use nouns and passive sentences as labels for these diagrams. All our arrows must be labeled, to the exception of the arrows that originate from a data store or ends up in a data store, because the name could be inferred from the context of using that data store. For illustration purposes, look at a very simple payroll system, which is used to pay workers based on their weekly timesheets. This diagram uses our notations, and we can easily see, for example, we have one external entity or agent, and that's the worker. So the worker is the only external entity, and it's interacting with the system. The primary input is the weekly timesheet, and the primary output that the worker will receive is the check. We're using three databases: the employee records, the company records, and the tax rates. So far, for example, add overtime pay, the name of your process conveys very specific meaning, and it gives the reader a complete understanding of the action that takes place at that point. This diagram, first the employee record is retrieved using the employee ID that's part of the weekly timesheet. Um, from the employee record, the overtime rate and the pay rate are obtained. These rates combined with the regular hours and the overtime hours used to compute the pay and the total pay. Subsequently, we're deducting taxes and recording that in the company records. And finally, we issue a paycheck with the net pay to the worker. The first step in this validation is to make sure that all of our um, inputs and outputs are labeled, and you see like those red arrows are the data flow items, and they are very simple to read, and they can be read by technical and non-technical professionals. And once we have a full understanding of these notations and the validation that takes place at the basic validation that takes place at this level, we can transition to the process of modeling and using engineering principles like abstraction and partitioning to build a hierarchy of data flow diagrams to describe the system. And these diagrams can be the foundation for deriving an architecture of the system. Happy modeling, and thank you for listening.